Alright, so as we know, we are using a line scan camera, and the advantage of this being like we can run the bot on any two colors that has a considerable contrast. So the way that we first achieve that is once we select the two colors for the track as well as the background, we have to calibrate against the lightest color on like either whether it's a background or the track. And the way it's done is what we do is we take the lighter color, in this case it's yellow on black, and so what we are doing is basically we take the background and we set it to the lightest color, and we try to bring all the pixels that are within the 128 linear array to the maximum value. So we are calibrating it. The way we start calibration is by pressing on this button, push button 0. And once it comes to that point, then it will give you an indication on this green LED saying that the calibration is done. And what we keep doing is during the calibration phase, we keep on increasing exposure time so that it sets up properly for the whole rest of the scans. And one limitation that we have is once the calibration is achieved, we assume that all our lighting conditions and all our colors are going to remain the same. And so to proceed with the rest of the track, Sharnav will explain to you what are the different cases we are covering on this track, meaning that the corner cases and all that. And it's over to Sharnav to talk about it.
So now we are running our bot on the test track that we designed for it, which covers pretty much all the cases, all the challenges that can be thrown in a track. So here it just crossed over a break in the line, which are on the same alignment, by the way. And there, as you can see, it is trying to take a turn on a 90-degree angle, and whenever it misses the turn, misses the line, it backtracks and tries to find the line again. Hopefully we'll make this time. And it did. And there we have another break in the line, which are, these two lines are kind of far apart from each other, so they're not in the same alignment or the same line. And there we have a complex intersection, and we have another 90-degree turn coming up. And here we have a turn with an angle which is greater than 90 degrees. On an intersection, it did not get confused, just went ahead. And there we designed the curve for it. And here we have another turn with an angle smaller than 90 degrees. And as you have noticed, there was absolutely no jitter on the bot all this time when it was traveling, so it's as steady as a car and no zigzag motion whatsoever. And now we will try to run the bot on memory mode, where it is supposed to do exponential performance optimization. And as you can see, the speed went up quite a bit, but well, it missed the track there, so it's just trying to backtrack again. Take the turn there. And the speed, the improvement on speed can be noticeable very easily. And it slowed down there because it already knew from before that there was something complex coming up ahead, and it slowed down for that. And the same thing is going on here, because when the first time it traversed around the track, it knew that these angles were the places where it had to slow down to make the turn successfully. And as you can see, it is still running on the memory mode, taking the curve nicely. And the 7-segment displays on it actually shows the location of the SRAM, wherever the data is stored right now and wherever it's getting it from. And the LEDs here, it actually shows the line that the camera is seeing. So as you can see, the line moves through the LEDs as the bot. So right now there is no line, no LEDs lit on it because it wasn't seeing any line, and the LEDs are back now because the line is visible again. And it traversed around the track a couple of times. The first time with on the learning mode, of course, and the second time using the memory with a much improved performance, in regards to velocity and knowing in regards to path prediction, knowing what is coming up ahead. And I guess this is a successful completion of the track for LILTIA. Thank you very much. So this is the second track that we designed to test our bot on. And this is obviously a track where you can see the background is darker than the line color. And as we already described before, the bot, LILTIA, can actually work on any different color as long as there is a fair amount of contrast between the line and the background. So now this path we designed to test how good it behaves on a very complicated intersection. So we have an intersection where 6 paths are crisscrossing each other. And now it's just trying to make the 90-degree turn properly. And there it is, made it successfully. And now we are going to try an obstacle and see what it does when an obstacle shows up. And there, it just took a complete 180-degree turn, turned around and found the path again, and going on it. And now we can actually turn obstacle detection on, turn off, which I just did, and so it does not see the obstacle anymore, and goes and completely bumps into it. And we can turn it back on again, which I just did. This control is on push button 3 of our FPGA board, of our DE1 board. And there we have a break in the line. And as I turn the obstacle detection on, I'm going to put the obstacle back again, and as you can see, it detected the obstacle and turned around completely on 180 degrees. So there it is. We covered all different complex scenarios that can be presented on a track, and this is where we finish our successful demonstration for LILTIA, light integrated, line traversing, intelligent automobile. Thank you very much for watching. You all have a good day.